Okay, this is your homework on, what's today? Wednesday?
Yeah.
Wednesday, October 17th. Wednesday, October 17th. Homework. This is actually Unit 3, Homework 1. It's the first homework from Unit 3. So here we go. Just want to check to make sure you understood what we did yesterday. So it says, let's do number 2 first. I know that's kind of weird, but number 2 is a normal one. So the base in this one is 3. Okay, the base is 3. What that means is that this is going to exponentially grow by a factor of 3, but you don't need to say that. There's only one transformation in this problem, and it's this -2 right here, subtraction of 2. So you would say that it goes down 2. That's what this means when it says describe the transformation. But what does down 2 mean? It means that your asymptote, instead of being y equals 0, is going to be y equals 2. So that's the first thing you're going to do in this problem, is you're going to come down to this graph, and you're going to draw an asymptote at y equals 2. -2. Sorry, this is negative. That's a -2. So -2. Okay, so there's your asymptote. You guys are okay with that? The asymptote alone will give you points on the next test. Okay, so the next thing we're going to do is we're going to graph. Okay, so we're going to graph 3 to the x minus 2. So here's my calculator. You guys see this? It's warming up. Do not show this message again. We'll say that. I said no. So we're going to go to y equals. Clear this out. Are you guys ready? We're going to type in 3. Now, to raise this to the x power, there's a caret. See this caret symbol right here? See this caret symbol right here? That's how you raise something. So press that. And then x is right here. Here's the x button. You guys see that? Right underneath mode, right to the right of alpha. It says x comma t. That's where your x is. So 3 to the x. Let's go back to our screen. Minus. Make sure it's minus and not -2. Oops, wait, that's wrong. You see how my 2's up there with the exponent? That's backwards. I got to delete that. And then delete this. All right, we need to press right arrow. So now it went down to the regular side and then -2. Your graph should look like this right now. I mean, your y equals. Now, if you press graph, if your graph doesn't look like this, try pressing zoom 6. This is showing an exponential growth. All right? And you'll notice that it started out by almost looking like parallel, or the actual, remember how the asymptote was y equals -2? This almost looks like the asymptote y equals -2. It's going to be right above the -2, and then it's going to curve up. It looks like it's hitting 0, -1, and we're going to need some other points, okay? So we know what it looks like. Now press second, right here, press second, and then press graph, because above graph is the word table. And if your t-table are not nice numbers like this, bring up your calculator and I'll show you how to get those to normal numbers. But you're just going to look for some nice numbers. Like, I don't like the negatives. I don't like those decimals. But I do like these 3 right there in the middle. Do you guys see these? 0, -1, 1, 1, and 2, 7. So it's kind of just, 325 is a nice ordered pair too, but 25 is too big. So you just kind of try to find 2 to 4 ordered pairs that look nice enough to graph on the graph that's provided. So I like 0, -1. So 0, -1 is right here. I would be grading that point. That's going to be points. There's also 1, 1. You see that? And 2, 7. So 1, 1 and 2, 7. It looks like this. And then you just kind of follow the asymptote. And you go here. Okay? And that's your graph. So not only do we graph it with 3 points, we have an asymptote drawn, and we describe the transformation we said down 2. All that's done. So let's go to the first one. Now, the asymptote's always 0 unless you have something added or subtracted at the end, and we don't have that. So this is kind of like saying plus 0. So the asymptote is 0 because there's nothing being added. So I'm going to start by putting in my asymptote here. There's my asymptote. The base is 2. Do not describe anything with the 2. But we are going to mention this 3. This 3 is a vertical translation, or actually let's say vertical stretch by a factor of 3. So you say vertical stretch by a factor of 3. And this minus 1 right here, because it's with the x, you're going to say 1 to the right. Move everything 1 to the right. Now, when I say that, what I mean is there's always a point. Let's see if I have a pencil somewhere. All right, there's always a point at 0, 1. On all exponential graphs, there's supposed to be a point at 0, 1. So what this is telling me to do is vertically stretch that unit of 1 by 3. So it would be up 3. And then this right 1 means go right 1. So there should be a point at 1, 3. That's what it's telling me. But you don't have to worry your little heads about that because you can punch this in your calculator. So we're going to go to y equals. We're typing in 3. Let's clear this out. Press in 3 times the base 2 raised. Now, a lot of you guys with old calculators right now are going to need parentheses. I'm just going to put parentheses in here, but if you have a new calculator, you don't need parentheses. Type in a parenthesis and then type in x minus 1, close your parentheses. That's what it should look like. Press graph just to make sure it looks like a growth, because it should be a growth because the base is 2. See how it's kind of running around the horizontal asymptote of 0? And it goes up. All we need is some t-table points, so press second graph. And look for the nicest points. Like, I don't like any of those decimals right there. I like 1, 3, and 2, 6. And I actually like 0, 1.5 too. Even though it's a decimal, 0, 1.5 is easy to graph. So I'd probably graph 0, 1.5 right there. And I'd graph 1, 3. And the next one I see on the graphing calculator is 2, 6. You guys see that? 2, 6. So 2, 1, 2, 3, 4, 5, 6. And then that's good enough. It's showing, so start it. When you graph this, start really close to your horizontal asymptote without touching it. And when you start seeing those points curve around, hit them, and go here. What if I asked you what the domain and range is of this problem? Your domain goes left forever, and it actually goes right forever. So you would say all real numbers. Your range is your asymptote to infinity. Your asymptote is 0. So you're going to say 0 to infinity. So you always start with the asymptote, but you put a parenthesis, because a bracket, if you put a bracket, it means it would touch 0. The reason we have a parenthesis is because we start at 0, but we don't touch 0. And that's how you do domain and range. So in this next, on the number 2, the one we already graphed, the domain would be all real numbers, but the range would be the asymptote. What's the asymptote in this problem? The asymptote's -2, so you'd say -2 to infinity. Now let's do 3. So what do you notice about this -4 here? This is a down 4. That means your asymptote's at y equals -4. Start by graphing that. All right, and then this 2 in the middle, put parentheses around that. Put parentheses around this right here. Is this 2 right or is it 2 left? This should be 2 left. So what that means is that there's always a point at 0, 1 on these graphs, at 0, 1. So what that means is if I went 2 left and down 4, I should have a point right here without even looking at my t-table. Let's see if I'm right. Let's punch this in the calculator. Go to y equals, clear this out, type in 4, caret. I'm typing in parentheses because the exponent is more than one number. Right arrow to get out of that, and says press -4. Graph. See how it looks like it's starting at -4 and then it curves up. Now, you see this? Be very careful when you draw this. It's not really going into the first quadrant right off the bat. It's kind of staying on this side of the y-axis. So let's look at the t-table points and see which ones we can get graphed. Do you guys like -2, -3? I do. I like -1, 0. 0, 12 might be a little high, but I still think I'm going to try to graph 0, 12. So we're going to go -2, -3. Oh, look, there it is. -2, -3. I was right. -1, 0 is one of them. And the other one is 0, 12. Which is about right there. If you put that in the graph, see right there? I'm just going to pretend like it's right there. Now we're going to follow the asymptote and go straight up, keep on this side of the y-axis until you hit 0, 12. After 0, 12, it starts going into the positives. And that's your graph. So what would your domain be in this problem? All reals. What's your range? What's your asymptote? Your range is your asymptote, parenthesis, asymptote to infinity. All right, this one right here, forget this whiteout part. I changed it. The reason I changed it is because I want a decay. Whenever your base, in this case, your base is 1/2. Whenever your base is less than 1, it's a decay. So this problem is a decay because of the 1/2 base. But there's only one transformation. The transformation is 1 up. So the transformation in this problem is 1 up. That's all you would have to say, 1 up. So let's go ahead and draw a horizontal asymptote at y equals 1. And the rest of this we can get from our calculator. So we're going to go parentheses 1 divided by 2, parenthesis, raised to the x, right arrow, plus 1, graph. This should be a decay, so it's just come here and come around. There it comes, see? That's what a decay looks like. We need a couple order pairs. I like -3, 9, -2, 5, -1, 3. I like 4 of them this time. There's 4 of them that are nice. So let's go 0, 2, -1, 3, -2, 5, and I also like -3, 9. So there's my points. Get close to the asymptote without touching it. And there you go. What's your domain in this problem? All real numbers. What's your range? What's your asymptote? Asymptote is 1 to infinity. That's it. So on the back, all you have to do is describe the back of this. Since I wrote with red marker, you can't kind of see this. All right, can you guys see this okay? My red marker's come through. Let me go get a clean piece of paper so my marker doesn't go through this. Here we go, it's better. All right, so we have basically 3 transformations. We're going to call this number 1. We're going to call this transformation number 2, and this transformation number 3. So number 1, what does a 1/5 do to the problem if it's on the outside of the function? So anytime it's on the outside, it affects the y, so we're going to say vertical shrink because it's less than 1 by a factor of 1/5. So you know that point that I always say is 0, 1? It's always 1 higher. You would only go up to 1/5 instead of 1. Okay, number 2. Number 2 is the one that's with this x in the exponent. Since it says x minus 2, it does say that, right? No, it says x minus 7. I can't read it. It says x minus 7. You take the opposite of the sign and you say it's going to go horizontal. It's going to be a horizontal shift. Right 7. If you just say right 7, I'd give you points. All the points. But it's supposed to say horizontal shift right 7. So anytime it's with the x, you say the word horizontal. And then the third transformation is this 5 right here. It's considered on the outside, just like the 1/5 is on the outside. The 5 is on the outside. I mean, I'm talking like separate than this term right here. So this 5 right here is going to be a vertical shift up 5. That's the proper wording. But I'm okay if you just say up 5. That actually also changes the asymptote. If there's a number on the outside, that means your asymptote is y equals 5. That's what that means. Okay, that's all you have to do on that problem. 6. So we're going to describe this negative first. We're going to say this is 1. 3 is 2. The negative in front of the x is 3. And the negative 1 is 4. So first transformation is the negative. When you have a negative on the outside of a function, it changes the y. But what that really is doing is it's reflecting over the x-axis. Let me show you so if you have something like this, like a growth problem, and there's a negative on the outside, what you would do is you'd reflect this over the x-axis and it would look like this. Get a pen that works. That's what a reflection over the x-axis means. So that's what a negative on the outside does. Okay? So the second transformation is the 3. The 3 is a vertical stretch by a factor of 3. It's on the outside, so it changes the y, vertical stretch by a factor of 3. So that point that would have been at 0, 1, first of all, on the reflection would have been at 0, -1. So it wouldn't be here anymore, it would be here. And then the vertical stretch 3 means instead of going down 1, you would go down 3. So there's actually a point right here. So it looks like this. Then number 3, there's another negative, but this negative is with x. So if it's with the x, you're going to say it's a reflection over the y-axis. So anytime it's with x, it's a reflection over the y-axis. Anytime it's out front, it's a reflection over the x-axis. And I didn't write the x-axis on the first one. Go back to number 1. That's supposed to say x-axis. This one's y-axis. So that means like this graph right here, then still have that point -3, but it would look like this. Reflection over the y-axis. So now it's like this. And then number 4 is down 1. Everything's going down 1. So you take this whole graph and just move everything down 1. So it's probably something that looks like that. But you don't have to graph it. You just have to describe these transformations. And that's all you have to do. That's the homework.